Hello, everyone. Croeso mawr. I would just like to say welcome to everybody and thank you for joining us this evening on a beautiful summer's evening. If you have any questions as we go through the presentation, if you can put them down in the Q&A box, which you'll find on the bottom of your screen, and then we will go through the questions at the end of Darrel's presentation. So we are very pleased to say that Darrel is joining us from South Africa this evening. So if we have any internet problems, please bear with us. Professor Darrel Abernathy qualified as a vet from the University of Pretoria, South Africa in 1985. He has since worked in Northern Ireland as a state vet and epidemiologist. He researched the epidemiology of animal diseases that impacted on both human and animal health, particularly bovine TB and bovine brucellosis, both in Northern Ireland and in Botswana. He obtained a Master's of Social Science, postgraduate diploma, and a PhD in veterinary epidemiology. And in 2012, he returned to Pretoria as head of the Veterinary Tropical Diseases Department before serving as Dean of the Faculty of Veterinary Science from 2014 to 2017. In 2018, he continued his research in animal and public health in the Centre of Veterinary Wildlife Studies. And then thankfully, in 2020, he moved to the place we are all blessed to call home, Wales, to begin at the School of Veterinary Sciences at Aberystwyth University. Darrel is passionate about 3 Ps: people, penguins, and programmes. With the people, it's from teaching to researching social sciences as factors in disease control to how wildlife can alleviate poverty in rural Africa. Penguins, the African variety, representing the avian research he has led. And programmes, understanding how health programmes in animals and humans can be improved and optimised. And now I'll hand over to Darrel, and hopefully you'll all be able to hear him and see his screen. Over to you.
Thank you, Bev. Good evening, folks, or good afternoon, or whatever it is, and welcome. Really nice to be joining you from South Africa. When John asked me to do this presentation, I warned him that I would be out here, and so we decided still to go ahead with it. We've had some technical challenges. They say you can't live in Africa without experiencing them, but hopefully we will get through the presentation pretty, I hope, without any problem. Let me just share my screen. Okay, so the title we decided on for tonight was Epidemiology for the Busy Practitioner, Why It Matters That You Should Have Listened More in Vet School. And I suspect many, if not most of you, went through your epidemiology training a little bit like the slide, which was deliberately concocted this way, which was lots of pictures, lots of graphs, lots of charts, don't understand any of it, too busy, and the shutters came down. Well, when thinking about what we're going to cover tonight, I decided to keep it very low level, not to insult you, but simply to get across a couple of concepts that I think are important, because I believe every vet, as every doctor, and anybody who does anything to do with data can actually function as an epidemiologist. So what is tonight not about? I am not here to persuade you to become epidemiologists. It'll be a lovely dream. I think if everybody was in epidemiology, there would be world peace, there would be no global warming, there would be no COVID, the world would be great, it'd be utopia. But also at the same time, I don't want to put you to sleep with highfalutin names, models, and formula, most of which go above my head. So I decided to keep it quite simple in its initial approach. And all I want tonight is to talk about data. So we're not going to talk clinical epidemiology versus molecular epidemiology versus global epidemiology. We're simply going to talk a couple of concepts that I want to persuade you takes numbers and transforms them to data. Why? Well, I think most of us are used to dealing with numbers. We've come through vet school, we've come through vet programs, we did pretty well at maths, etc., etc. So we're used to numbers. But I want us to take it a little bit further and to start thinking in a different way about looking for patterns. And the idea is that we can have fun. So this is not to become great scientists, not to produce great papers, but I think in the way that you can use the data to make your life as a vet slightly more interesting if it's not interesting enough as it is. So here's the objectives. Talk a little bit about data and making sense of it and how you move numbers to data. We're going to talk about diagnostic tests, really just the basic principles all the way back to third year, if that's when you did your epi, and 2x2 tables, another basic element that's really the foundation for fairly sophisticated studies that epi people do. And going to finish then with just the basic principles of outbreak investigation. The idea is simply to give you a taster of some of these concepts. We hope to run a series of talks on epi subjects in more detail later on, but this is just to give you a little feeling. And then we'll finish with how we take it forward. So I'm going to move rapidly on this because Bev's already covered this.
I'm not sure I understand.
Just to let I'm largely in South Africa at the moment because we've got a number to come out here at the university. So I've got to put a plug in for the vet school. Most of you, I'm sure, will be aware by now that we're running this joint degree, which will do their first 2 years with us at Aberystwyth. They're currently responding. We're already over quota. So that's a very good start. And last I looked, at least half our students are coming from Wales. So that's really exciting and very positive. We won't lose track of the students when they go to RVC because they will be coming back to Wales to do at least their half their AHEMS or their EMS, the clinical EMS in Wales. If you're not aware of it, please, can I ask you, we've got a survey out there. We are canvassing views about the vet school, its value, its role, who should train. If you've completed the survey, thank you very much. And please, though, encourage others in your practice, in your network, vets, nurses, senior managers. The more views we get, the better that we can actually respond to the needs and the opinions out there. And there is, of course, a little prize as a thank you. There's a little bit of a lottery to incentivize people to participate. So please, if you haven't done so, please participate, encourage others to do so. Didn't know whether to take a large livestock example or a small animal and pet example, so I went for something completely different. Poultry. Here you have a true life disease outbreak. And as you can see, the eggs in the bottom right are normal. As the disease starts to go through the flock, the eggs become thin-shelled, they crack, they break much more easily, they lose their color, till eventually the birds stop laying down calcium and you get eggs just with the membrane. If you were a vet, particularly if you were a general practitioner or a small animal person, and you were called to a poultry farm, no experience of poultry, and the guy or the lady had a disease problem, this is what you might see. So this is made up data, by the way. The outbreak I'm going to talk about is genuine, but the data are made up. And some of the facts are changed to protect privacy. But let's assume you're in a layer flock, and if you look at the farmer's records or you make your own calculations, what you might see is that for the previous number of weeks, mortality has been between bad eggs has been between 0 and 10, and then all of a sudden it starts to climb. Easy. Those are numbers. And if you're sensible and you're not a poultry specialist, the first thing you do is you run back inside, you phone the poultry specialist and you stand back and you wait for them to take over. But you can do far more. And that's when numbers become data. By asking a few questions and looking for patterns, because essentially that's what Epi is all about. It's looking for patterns. It's asking, in the big bad world out there, is there a pattern that I can see? Do these events, be they diseased animals, be it dysplasia in a breed, be it hair loss in certain chinchilla animals, whatever it is it occurring randomly? And if it is, that's fine. If it isn't, why isn't it? And so you can ask here spatial patterns. Where are these eggs happening in this house? And this little scheme at the bottom simply illustrates that after the first house was infected and subsequent houses became infected, what we found was, by the time we arrived, there were multiple houses infected. But it was interesting, in most of the houses, the layers that were having the problems were located very close to the air vents. And immediately, we're now, as we're talking data, are being able to ask questions about how this disease is spreading. If this were a disease in the feed, we would be expecting it either to be well distributed through the houses, or depending on where it happens in, it would be in birds, if they're on floors, birds that were clustered around feeders. But what we have here are layers in cages, some barn houses, and the birds are clustered to the air vent, suggesting, which turned out to be the case, that actually most of the houses were infected by air passing from infected houses into non-infected houses. We then ask questions around the type of houses. And for those of you who've forgotten all your maths and all your epidemiology, by simply creating 2x2 tables, you can answer some very interesting questions. So here we have on the one side, the type of house, on the other side, the disease. And in the 2x2 table, we can now populate it with our findings. And we can see odds, which of those of you have forgotten is the ratio of one cell to another in terms of cage from positive to negative, the odds of barn positive to negative, and the ratio of those two shows that the chances, or crudely speaking, the probability of finding the disease in the cage birds is more than 1.5 times than in the barn birds. So we've taken what was simply a number of eggs, and we would have run away to find a poultry specialist by asking very basic questions, collecting very basic data. We now are able to generate at least some research questions and some hypotheses about where this disease might have come from and or how it might have spread in the house. Let me give you another example while we're on the subject of poultry. Again, these are true data. This is a large poultry flock, multiple house that went down with disease. This is of Newcastle disease. This is the 3 kilometers, 10 kilometers. This is a map of all the poultry farms. What do you observe? Simply by drawing a map, plotting the positive and the negatives, one gets a very clear impression that the disease seems to be more in the right top-hand quadrant than in the rest of the zone. By simply plotting the disease, we're able to ask a question, why? How did it get like that? Is that random? Is that by chance? Or does that tell us something about the disease? And for the sake of time, and I promise not to show you any fancy models or something, what we found was what's called the hazard rate for the houses or the farms that were downwind of that farm were much more likely to get disease. In other words, after doing the investigation, I'll come back to it later, the predominant wind direction when this guy went down with disease was from the southwest, and it's most likely that wind-borne spread caused this mini epidemic. That was actually one of the first times that wind-borne spread to this extent was shown to be significant in any way for this disease. What am I saying? I'm simply indicating that by mapping out the data, this could be your client's herds. It might be herd health data. It might be locations of a condition in clients' pets. It might be locations on a farm. By mapping it out and seeing if there's clustering or apparent patterns, you can lend yourself to doing epi, having fun, using your brain cells, and yet generating some interesting research questions. Second thing I want to talk about are diagnostic tests. Now, again, you deal, I'm sure, if you're a practitioner, with tests day in, day out. If you work in the regulatory field, what I'm going to talk about in terms of the tests for TB or brucella are bread and butter stuff. But very often we get a test result from the lab. It doesn't matter whether it's small animals or large animals, but we fail to think through what it actually means. Let me explain to you. This was a study in which I participated in. It was done by Weybridge in 2018, and it looked at the literature and all the reports that met quality criteria for TB testing, sensitivity and specificity. And so the question is, what's the sensitivity of our skin test? Does it matter? Do you care? Well, before we get to that, let me take you all the way back to those early epi or probably your science classes at school. And let's talk about a standard 2x2 table, because for diagnostic tests, this is bread and butter. And again, by populating some fields with a little bit of data, you can ask and hopefully answer some very interesting questions. So if we simply take the test positive or negative, the disease positive or negative, plot out the cells, we can then generate a number of parameters that help us understand how diseases are diagnosed. So first of all, we know this well, sample prevalence. You can test a certain number of dogs. You can test a certain number of cattle. In a herd, between herds, you can test herds. You will get a value. And of course, we know that that numerator, which is the animals or the herds or the units that test positive, will contain animals or herds that are truly diseased and a proportion that are negative. That's what's called sample prevalence. Of course, it's not a true prevalence because we've got potentially a number of non-disease that are positive for the test. And we've got ways of calculating what might be the true prevalence. What's more interesting is the sensitivity of the test. And it's interesting to see that this parameter deals solely with disease. We've got a population of animals that have the disease. What proportion of them are picked up by our test? So the numerator is the truly diseased animals that are test positive. The denominator is a mixture of diseased animals that were picked up by the test and were negative. Specificity, much the same thing, except these are negative animals. So the denominator are all the animals that did not have the disease. The numerator are the animals that truly were negative, and the false positives form that proportion that affects the specificity of the test. In other words, sensitivity has to do with false negatives, specificity has to do with false positives. What's less widely used is a thing called the predictive value, the positive and negative predictive value. It's been interesting to see with coronavirus how sometimes when we have the news briefings, either reporters or ministers, or dare I say it, even some of the scientists get muddled up between predictive values and sensitivity and specificity. Predictive value has to do with the test result. Sensitivity had to do with disease. Test predictive values have to do with those samples that have tested positive or negative. And a positive predictive value is, I've got a positive result. What's the likelihood that it's truly a positive? Negative predictive value, exactly the same, but for negative results. We tend not to use predictive values much because they're very affected by prevalence. If you have a very low prevalence, you get distortion of the figures. So we tend to use sensitivity, specificity, but they actually mean slightly different things. So what you say? You're talking just like I heard my third-year lecturer talk. The shutters are coming down. Well, let's talk practically. That paper that I showed you earlier had a median sensitivity, reported a median sensitivity of 50%. What does that mean? Well, when we looked at all the reports in the literature, half of them had sensitivities under 50%, half of them had sensitivities more than 50%. Median, 50%. Let's assume that's the true value. What does that mean? That means that in 100 infected cattle, remember, we're dealing with disease now, we're dealing vertically over here, our test is going to pick up 50 animals. Better really than tossing a coin. What is the sensitivity for breast screening? I think most of us accept that the screening test in the UK has done a fantastic job at detecting what is a very terrible disease. Sensitivity of the screening test, when last I looked, and I think the data were from about 2018, was 85%. What does that mean? For every 100 women that are screened for breast cancer at the first test, 15 of them will be missed. Think of the implications of that. Pretty horrendous. You go for a screen, it comes up negative, but actually it's a false negative. The specificity, on the other hand, is 90%. What does that mean? For every 100 women who go for screening who don't have the disease, 10 of them are going to come up positive. And think of the implications of that. That they go home thinking they've got the disease, but they don't really have it. So the implications of the sensitivity specificity can be quite profound. Just to throw in, to balance it, keep gender equality. If we think of the PSA, I think it's prostate-specific antigen, yes, PSA test for prostate cancer, the sensitivity is about 67 to 80%. In other words, between 20 and 30 men who have prostate cancer will be missed by using that test alone. Specificity is about 91%, so pretty close to the breast screening. And the reality is that most diseases, when we develop tests for them, have imperfect sensitivity, imperfect specificity. And the people who design the test and the policymakers have to try and get it right. Is it more important that I have fewer false negatives? Or can I live with more false positives? Although sensitivity and specificity are not the different sides of the same coin, they are related. By adjusting test thresholds, I can improve sensitivity, but generally it's at the cost of specificity. So when we talk TB testing, for those of you who have had the privilege of, I don't know what you call it, of testing countless animals, I've done my many thousands animals, so I'm able to talk. we have a response. I have met vets who tell me quite openly, they tell the clients, don't believe the test, we'll handle the disease ourselves, get that animal into the abattoir, the test is rubbish. That's what they tell me openly. Well, I hope that's not how you behave. There are ways of improving sensitivity. We repeat the test. That's why you'll know with TB testing in this country, if you find a positive, the herd has to go through repeated tests. That's not only to detect latently or quiescent animals, but it's also to improve the sensitivity. We can use parallel testing. I'll give you an example of that just now, where we throw multiple tests at it. That has a consequence for sensitivity and for specificity. Or we can use targeted testing. If we know, for example, with TB, we know the age-specific incidence, in other words, the incidence in each category of animal tends to increase as they get older. By targeting older groups of animals, we can improve that. So my question is, what do you tell your client? I know certainly from years in Northern Ireland, many farmers have lost faith in the test. They say the test doesn't work. And we all know the reasons. That's not the purpose tonight. What I'm trying to get across to you is that if you've forgotten these concepts or you never knew them, it's important to try and persuade the client what the reality is of biological tests and how we can work to try and make them more effective for their purpose. That same paper reported the specificity of the test at extremely close to 1. I've abbreviated to 1 here. Well, what does that mean? 100 non-infected cattle, we can expect no false positives. And you say, I don't believe it. That's rubbish. Of course we get false positives. Well, let's explain it like this. According to hundreds of papers, when you condense them, you put them together, what it says is the skin test throws up very few false positives. If you have a specificity of 99.9%, that means that you're going to get approximately 1 in 1,000 as a false positive. However, because it's a screening test, because like in Wales, we're doing over 2 million tests a year, we can expect over 2,000 false positives with a test that is 99.9% specific. Again, what do we tell the client? We have to believe in the test ourselves, and we have to say that we're trying our best to make it extremely effective. Now, I promise not to throw numbers. Don't worry about the detail. What I want to show you is that by altering thresholds, we can change the sensitivity and the specificity. So hold on to your horses. Stay with me here. This top number is we use one particular screening test, the serum agglutination test, and we get, in picking up 148 culture positive animals, with this test at this threshold, we found 82% of them. Not very good. We could tighten up the sensitivity. By dropping the threshold, we improve the sensitivity. But look what happens to the specificity. It drops significantly, showing this balance we have to get. If we use a screening test with a confirmatory test, by using the confirmatory test, we significantly damage sensitivity. Now think back, for those of you who are large animal practitioners doing a skin test, why we use severe interpretation. We increase the sensitivity, but we know it's going to affect our specificity. If we bring in two different tests, we use them together, we can increase the sensitivity, and in this particular case, we don't really affect the specificity. What am I saying? By playing games with different tests, we try to get to this optimal balance of having the best sensitivity and the best specificity. And you say, well, how does that work? Well, what these tests are doing is essentially picking up different but overlapping populations of animals. If you have a look on the left, this is for brucellosis now, 150 culture positive cattle. All 3 tests picked up 2/3 of them. So if we only had 1 test either way here, we would pick up roughly 2/3 of these infected animals. But these are the numbers that are very interesting here. The ones that are outside on the Venn diagram, because these are the animals, all look on the right side at herd level. These are the herds that were detected at the first test by only 1 test. What does that mean? Well, in the herd example, we found 64 herds would have been detected at the first test, irrespective of the test we use. If we only had the SAT, we would have missed these 10 herds, or these actually 11 herds, that were picked up by the other tests. And that shows you the value of parallel testing. Why is that important? Well, if again you're working with, I'm aware of TB, but it does apply to some other small animal tests. If you're going to use 2 or 3 tests, you're going to have to define what is a positive test result, and do you act on the basis of animals or herds that are positive to multiple tests or only 1 test. And so particularly in Wales with chronic herds where the government is throwing lots of different tests, it's no surprise then that you can see from this Brucella example that you probably would get a parallel happening with TB, that these different tests will pick up different populations, but overlapping populations of infected animals and herds. This map is just a little aid memoir to me, which goes back to foot and mouth days. Northern Ireland only had 4 primary outbreaks. You can see them illustrated with difficulty by these stars. There were actually 2 over there. There was 1 up in the northeast of the country. We strongly suspected that sheep were involved in the epidemiology of the disease, and a decision was made to test virtually every flock in the country, particularly starting with those in certain zones. What did we find? We found dozens of test-positive sheep. And it created a big debate in government in Northern Ireland as to what you do with those flocks. Foot and mouth, the mythical disease, the ultimate terror. So what do we have to do with the flocks? Some people advised that we should slaughter all those flocks. Other people counseled that these were not truly infected animals or flocks. They were only false positives. And I'll spare you the details, but it shows you it has a real impact. My final one I want to talk about are contingency tables. These are the famous 2x2 tables. And these are wonderful little tools for any budding epidemiologist or practitioner to use. Because by simply putting in some data, as I said in the beginning, it leads us to hypothesis and leads us to questions. I want to give you 2 examples that I got from the literature. Here's hip dysplasia. We know that hip dysplasia occurs in the large breeds compared to the small breeds. So I took out data here. Let's assume that you want to do a study of dysplasia. Let's say you knew there were lots of St. Bernards and Siberian Huskies. What could you do? Well, you could plot the St. Bernard data, the positives, the negatives, the total. You could plot Siberian Husky, and here's the numbers from this paper that I've referred to below. What you find is the risk, in other words, the prevalence of hip dysplasia in St. Bernards in this study was 0.94, 76 over 81. By contrast, in the Siberian Husky, it was 25 over 138. In other words, compared to Siberian Husky, St. Bernards had 5 times the risk of hip dysplasia. Why? Is it because the St. Bernards are particularly susceptible? Or is it because the Siberian Huskies are particularly resistant? Both large breeds, so it's not a large versus small breed. We can see, and this is well published, that even within the large breeds, there can be significant differences and risk factors, and it's much more genetic related to genetic strains than it is to particular breeds. Here's another example. This one comes from Africa, feline leukemia virus. By simply plotting the exposure, which is cats kept outdoors or indoors, and looking at negative positives and comparing them. Here we're using odds. So risk is positive over the total number. Odds are a ratio of positive to negative. We can see that the odds or the chances or a crude measure of probability of outdoor to indoor cats is significantly higher, 12.46. You say, why is that important? Well, all I'm trying to illustrate is that by simply thinking different and asking questions around how do I compare, putting data into a very simple 2x2 table, you can now move from numbers to data and from looking at just a pattern and looking at an association. So the example on the right with feline leukemia virus, what we're actually saying is outdoor cats are 12 times more likely in this study to have feline leukemia virus than indoor cats. And the question is why? And of course, what you can then do is you can get a whole lot of other risk factors, and you can also measure them. And then you can use some nice tools like logistic regression that asks, okay, is outdoor versus indoor significant after I adjust for age, after I adjust for breed, after I adjust for health, and for a number of other factors? And that's caused fairly classic a logistic regression study. You've moved from numbers to data, and you've now looked at association. But you have to be careful, because there's 2 little wobblers that will trick you, and I have to tell you about them. The first one is called a confounder. Let me give you an example. This again is the study looking at the risk of brucellosis many years ago. I did exactly what you saw with the leukemia virus study, looking at odds. And what I found was that dairy herds were 1.5 times more likely to have brucellosis than non-dairy suckler herds. In other words, they both had female animals in them, but the dairy had a much higher probability. Why? Why would you expect to see more brucellosis in dairy herds? I would have thought intuitively dairy herds were better managed, greater observation, earlier detection of abortion, earlier detection of reproductive failure. I would have thought the risk was lower. Well, the reality is that once we put herd size into the model, that association fell away. That association was it was confounded by herd size. So that's just a little warning that confounding can play a role. So you mustn't, once you've found your association, go, Yahoo, I'm the world's greatest scientist. I know everything, because sometimes these little wobbles can trip you up. Here's another one, exactly the same study. I asked the question, had these Brucella herds had TB in the previous 2 years or not? And what I found was that herds with TB in the last 2 years had almost 3 times the probability of having brucellosis than herds with no TB. What was interesting was it was still significant once we adjusted for herd size. Herd size is a very common confounder. Why? That's the first time that had ever been reported. first time anybody had ever thought that TB might be a risk factor for brucella. We don't know the answer is the true answer. We're still looking at it. It might be management. It might be that if there is human behavior at work in spreading TB, that human behavior might also spread brucellosis. Don't worry about the detail. What I'm trying to show you is that with very little data, but simply looking for patterns, in this case, looking for associations, one is able to ask some very interesting questions about possible associations, generate possible hypotheses, and have fun while you're doing your job. And here I'm really going to bamboozle you. This is my red flag warning to simply say there is a huge difference between finding an association and finding causality. In other words, if I find an association, there's a whole pile of steps I must go through, and these are called Hill's criteria for causation, before I can be confident that that association is truly causal. There, I've just listed them there simply as a warning to be careful. Finally, and I'm going to move fairly quickly through this, but I thought it was good just to give you some basic principles, and apologies if it's a little dry. Sometimes you're going to encounter clusters of disease. And that really is an outbreak. It can be in small animal practice, it could be in poultry, it could be in herds, doesn't really matter. So how do you go about trying to investigate it? And all I want to leave with you is 5 key headlines. Because what I want to show you is that very often outbreaks are only investigated retrospectively. And by that time, the data are poor, people haven't collected the data properly, and it leads to some very muddled conclusions. So if you are interested or you are involved in an investigation, there's a couple of clear steps, and hopefully one day we'll do a lecture or 2 or a couple of presentations. We will look at this in a lot more detail. First thing is to describe the problem. You may think this is teaching your granny to suck eggs. This is so obvious. Well, that was the very first time I encountered that primary flock with Newcastle disease. I scribbled lots of notes that I thought I could interpret. 6 months later, when I went to read them, I couldn't make head or tail of them. And it was only because the colleague left some very good notes as well that I was able to use his notes to actually describe the flock outbreak accurately. That applies, of course, to all diseases in all circumstances. The second thing one has to do is to establish a diagnosis. And not only that, but to look at what a case definition is. And, you know, I've been fascinated with the coronavirus outbreak, that we keep hearing vaccination has solved the problem. Or, in fact, only this last week, we got our AstraZeneca vaccine jabs early so we could come to South Africa. There was some question about the fact that the vaccine was effective against the disease, against the South African variant. And I got a shock 2 days later, or 2 days ago, to read in one of the news reports that a study had found the AstraZeneca is only 10% effective against the South African variant. Well, the question begs, what did they use to define a positive coronavirus? Was it a PCR test? Because I don't care about being PCR positive. I care much more about being hospitalized, being in ICU, or dying. Those are different case definitions. And when we come to disease, it's exactly the same. If I think about a TB herd, I can use multiple definitions. If I think of foot rot, many times we don't bother to culture the bug. We simply go on the clinical picture. So we must sort out what the diagnosis is and what the definition is. And then, and again, there's no detail here whatsoever. We need to explore it in a methodical, clear manner. And finally, once we've done all that, we put all the potential risk factors together. So that cluster of outbreaks I showed you of disease, this was what's called the causal web. These were all the possible causes of those black dots in that diagram that we had to work through step by step. And we had to tick them off to make sure that we had either confirmed them or refuted them. And the only one that was left in the mix at the end of it, in this particular case, was airborne spread. And finally, once we've got all the facts together, we can then talk about generating a hypothesis. In other words, we hypothesize this is where the disease has come from, this is what it's doing in this herd or flock, and this is where it's going. And that then guides the action plan. Finally, we're almost there. Where do I go from here? Well, first thing is you can have a cup of coffee and you can say, okay, that was boring, interesting, relevant, irrelevant, and get on with your life. That's great. Or maybe I've triggered some questions in your mind that you're thinking, oh yes, I've seen a certain problem in my canine population. I've seen a certain problem in sheep flocks. I'm going to try and think of exploring it further. Brilliant. The first thing you want to do is to then draft a very simple research question. And once you've got that research question, I can guarantee you it will get under your skin and you're going to try and answer it. That's what having fun with epidemiology is all about. I remember working under very primitive conditions in Botswana as a young vet. I was doing largely animal health, but I also did some work on the farms around. And I remember trying to look at liver fluke and trying to understand how could liver fluke be a problem in a country that was almost desert. I set myself a research question, and I can promise you it was very interesting because it galvanized how I referred farmers to problems, how I followed their cattle into the abattoirs, and how I started to look for liver fluke. And so what I was doing was I had the research question and I started to collect data. Of course, I must put up a warning. If you are ever going to collect data, just be aware we are in a world that is very conscious about privacy, very worried about ethics. So we've got to be careful how we collect the data. Thirdly, if you're interested in epi at all, there's a huge variety of things that you can do to further your case. There's a huge number of informal courses, there's CPD, there's a huge amount of material available on the web, on the Epi web, and people like Dirk Pfeiffer have put their textbook on the web for free, huge amount of information, and you can do everything from reading up informally to subscribing to CPD, masters, and even PhDs in the subject. Fourthly, you might say, I'm interested in the subject, I'm too busy in practice, too busy in government, I don't have time. Well, you can certainly participate in a study. What I would suggest you doing is if you've got a research question that you're very interested in, approach somebody in the university. Go to one of the vet schools, see if you can find a friendly epidemiologist and say, I've got this research question. Can you tell me how we could explore it further? Or next time you're confronted by a university who wants to do research, join the study. They do all the technical work. They do all the admin stuff. And you just get to enjoy the participation and contribute to their work. That's it. Thank you very much for listening. I'm going to stop sharing and we'll do any questions and answers.
Wow, thank you very much. That was amazing. For somebody who's interested in epidemiology anyway, I find it very interesting, and just dealing with postmortems and diagnostic testings in the Wales Veterinary Science Centre, a lot of it has lots of interesting questions for me. So we only have one question at the moment, so I think everybody's kind of chewing over what you've said. There's a question from Jenny Cook saying, thank you so much for this. A great reminder after a few years out of university. Apologies for leaving early. So that one's fine. And somebody else says, thank you very much. So it's great that the internet is lasting all those thousands of miles.
Absolutely, it's lasted. Thank you, Cyril Ramaphosa.
It's brilliant. So I should think of a question, really. So I kind of haven't really thought of one yet. Lots of people saying thank you very much, really informative. How excited are you about getting your first students come September?
Oh, great. Oh, hugely. I mean, the program has been worked at for years before I arrived on the scene. And it's been a huge effort by a pile of people. And I think when the students first step through the door, it will be a culmination of many years of hard work. So I think everybody's going to be really, really excited. Absolutely.
Fab. I have got a question here. Should we be able to eradicate TB from the UK Northern Ireland population using the tuberculin intradermal test? $1 million question.
No. Okay. But
that's a simple
the question I would like to phrase slightly differently. Should we be able to eradicate TB from the UK Northern Ireland population using any test? And I think the answer to that is no. And the answer is because wherever you've got globally a wildlife reservoir, countries have really struggled to get rid of the disease. If you think of Michigan, if you think of Australia, none of those countries have been able to eradicate. New Zealand have got rid of possums through the most incredibly intensive program. They haven't got rid of the TB. They cannot get rid of every possum. So will it spill over to cattle while it's in badgers? Yes. And I think what we can only really do effectively is in the long term. I know some of the models show we will be able to eradicate it. I just think it's going to be many, many decades with intensive testing if we're going to try and eradicate it while we still have it in the badger. People, that's my personal view. Okay, that's not government view. That's my view. I think it's going to be around a long time.
Have you read our recent paper? Oh no, it's not out yet. It's in progress. Okay, here's a COVID-19 question. Can the Hill's 9 principles of causation be used to explain COVID-19 vaccine side effects?
Oh, I tell you, that's a great question. I guess so. I don't know. I mean, it depends, I suppose, because first of all, I think people were scratching their heads, even asking about the vaccine side effect. When blood clots came out, people were bamboozled. Nobody really knew. To have a causal association, you must be able to map out the pathway. You must be able to go from the effect to the cause. And they couldn't even do that. So I suppose the answer is probably not, but I think they're looking at it.
That's a good one. Another question. Thank you for a really useful and interesting presentation. Will there potentially be scope in the future to provide data from practices for vet student projects?
Well, that's also a wonderful question. I hope so. I hope practices, first of all, let me start off by saying, the support we've had for the vet school has been superb throughout Wales, every group of people. I'm pretty sure that if we're looking for data and we approach practices, I'd be hopeful practices would participate. Our problem is, though, that students don't have to do a research project now in their first 2 years. It used to be that RVC had a research project in year 1, in which case we would have needed data. But now they've stopped that and they're focusing on in later years. But there always will be scope for getting data, even for doing further research projects for M students or something like that.
I was going to say, on the back of that, there are lots of other departments within the university that do want data, and us at the Wales Veterinary Science Centre, we feed in all sorts of data and samples from diagnostic tests sent to us, we feed in samples into the university. So there's so much going on at the university. There's always projects to help with from the parasitology group and others as well. So
yeah, just to go, Bev, sorry, just before you leave that one, just to say, of course, the problem always is when we approach people, it doesn't matter whether it's an abattoir, a practice, a medical hospital, data privacy is always the issue. You need clients' consent and ownership, and that's the big challenge. It's actually, you can't just walk into a practice nowadays and say, give me the last 15 years, I've got questions to answer. It has to actually be prepared in advance.
That's where we do quite well. We just have a tick box on our submission forms, and if nobody ticks the box, we're fine to use the samples. And obviously it's completely irrelevant to the owner's details. We ignore that bit. We don't send them that bit. So
absolutely.
Here's a question about vaccination for TB. Is vaccinating the answer to getting rid of TB?
Oh man, you can spend hours on these questions. Ask Glyn Hewinson. And in my view, yes. Okay. It's a way to live with the disease. It's a way to reduce the disease, protect the cattle population. Will we get rid of COVID through vaccination? We hope so. Will we get rid of TB and cattle vaccination? We hope so. We certainly will reduce it to negligible levels, I think, if we can get there with the vaccine.
Definitely. And then another question also on TB. Do you think then that if cattle were all moved to indoor lots in the UK, we would be able to eradicate TB?
Oh, where is my glass ball? Where is my glass ball? No, I don't, because I think cattle still spread disease. I can give you cases where we have had bulls standing in isolation for 5 years at bull testing station, and coming up with a strain of TB that was found on a farm that they had left 7 years before. In other words, that bloomin' animal had TB. It had been negative for every test for 7 years till it finally went down with disease. So we're moving them indoors. It might reduce the risk, certainly, of cattle contact at pasture, and it might reduce the risk of badger to cattle contact if it happens at pasture. But it won't be the only answer. The answer, I think, lies with a whole comprehensive package of measures. And that's another 5-hour talk some other time.
And that is exactly what the university are doing with the TB unit and Glyn Hewinson, and everything is feeding into the epidemiology work, and which is happening in Wales. Thanks to the Welsh government.
And absolutely. I was going to say that. Thank you, Bev, because, I think it's a huge privilege for the university and Wales to have somebody of Glyn's ilk and the team that he's got with him working in Wales. I think that's a huge privilege, and I think it's going to pay dividends.
And on the back of that, I'd just like to remind everybody who's listening that we are still wanting information of dead badgers, even if you think that they're unsuitable. The more dead badgers that we get into the Wales Veterinary Science Centre, the more data we have. And a new paper is being written. There's the paper that we published in Nature magazine a couple of years ago, and we're currently working on a paper which Darrel is helping us with slightly as well, aren't you? Or will be. And because of the sample sizes, which you said about in your presentation, by continuing the Badger Found Dead survey over many years, the sample size is growing and growing, and therefore the data set that we have is much better. And we've got another question here from Ivan Lloyd. He says, thank you, Diolch, for a very good presentation. Any comments on TB risk and herd size? Is it a multiplier or a confounder?
Hey, Ephraim, we were keeping it nice and simple tonight, man. Come on.
I mean,
okay, it's a great question. So it's been found for many diseases that herd size is often a confounder. But what does it actually mean? Because when you have herd size as a risk factor, it might simply be a proxy for the density of animals in a certain area. For any contagious disease, the higher the concentration of animals, the more likelihood of disease. So although we confine animals to discrete units called herds, in reality, when these animals are at pasture, or if you've got lots of small herds where they're being managed together, the distinction between small and large is actually quite difficult. So I think it's probably more of a multiplier, but what we mean when we say it's a confounder is actually, it's not on that causal pathway, but it's looking like it's apparent causality.
Fab, thank you. There's a question here that's probably I'm better off answering. Will there be an AberTB conference this year, live or virtual? The question is, we still don't know. I'm hoping to speak to Glyn in the next couple of weeks regarding this. Unlikely that it would be live in person, but who knows with COVID at the moment? We really don't know. There's some people trying to organise face-to-face CPD for the autumn. We don't completely know what the appetite is for it. Although people want to speak face to face and meet, you also don't want the risk of it. So we'll see what happens with that one. And I think that's the last question. So I'd just like to say a very big thank you to Darrel for joining us from South Africa. Thank you for BSAVA for helping with the webinars. And we just wanted to say that we're at the Wales Veterinary Science Centre. We're very excited to be organising some CPD, hopefully as soon as in the autumn, with Darrel and Aberystwyth University. And we will have, more BSAVA CPD coming up as well. If you'd like to receive any updates, please make sure you go onto our website, www.wvsc.wales, and sign up to our alerts. And then you'll get no more than monthly emails with updates of our CPD and CPD that happens across Wales. So that's all CPD. And thank you very much.